Okay. So today we'll discuss the relationship between alpha, beta, gamma, and we'll do some problem. Okay. Okay. So we know that the value of IC alpha equals to IC by I. What is beta? IC by IB. Now I want to find the relationship between alpha and beta. Okay. So how will proceed? We know the basic equation: emitter current equals to collector current plus base current. If I want to find base current, then IB equals to IE minus IC. Now I'll put this one in alpha or beta. So if I'll take beta equals to IC by IB, then I'll keep IC same, and in place of IB I'll put this one. So IE minus IC. Okay. So once you replace this one, then I'll find this term, because I want to convert beta in terms of alpha. So I want to find IC by IE term. So how I'll get, if I divide numerator and denominator by IE, then I'll get this one, IC by IE divided by IE by IE minus IC by IE. Okay. So what I'll get, IC by IE equals to alpha divided by 1 minus alpha. That implies beta equals to alpha by 1 minus alpha.
Will be circulated. It will be circulated in particular direction.
Clear?
It's not that it will circulate one direction and from here it is circulated from other direction, right? It is not.
So beta equals to alpha by 1 minus alpha. This one already you have discussed. If you go back to previous.
Now, from here, whatever input is coming to this port 1,
see this one,
is being directed to
alpha by 1 minus alpha, IC equals to beta IB. So beta equals to alpha by 1 minus alpha. And here also we have proved here.
And from this port 2, whatever input you are giving,
is it clear?
Directed to port 3. And here it will be coming as output. And whatever input you are giving to port 3,
now
that will be going as,
if you want to find alpha in terms of beta, then you cross multiply. What I have got, beta equals to alpha by 1 minus alpha. Cross multiply here, beta into 1 minus alpha equals to alpha, then beta minus alpha beta equals to alpha. Then you take alpha one side, so beta equals to alpha plus alpha beta. If you take common, I'll get 1 plus beta. Take this side,
so
beta by 1 plus beta equals to alpha.
It is a low pass filter. So signal.
So in this way, we have converted alpha in terms of beta and beta in terms of alpha.
High frequency will be, if the frequency component higher than the cutoff frequency, that will be blocked.
Okay.
Similarly, in case of high pass filters, it will pass the frequency which is higher than the cutoff frequency and lower than the cutoff frequency. Those frequency components will be blocked.
Any doubt?
Here, in case we are talking
have you written?
Yes.
Talking about optical filters.
Now, similarly,
So this fiber
you can find gamma and alpha relationship.
So
Gamma equals to
rough surfaces. Okay. Some,
IE by
surfaces, some permutation
IB,
which are
alpha equals
been,
to
done
IC
on
by
this, material.
IE.
The material.
So you just
So
find
this gratings
alpha in terms of
periodic.
gamma
This,
and gamma in terms of alpha,
rough surfaces are
and tell me what is
periodic,
the answer.
right? And they are repeated. You could see
In
they are
place of
repeated.
IB, you replace IE minus
And
IC,
the size of the
then try
grating
to
is same,
divide
size of
the
grating
term
is same.
through
Now
which
what
we can
happens
get
is,
alpha.
when the light falls on these surfaces at a particular incident angle, based upon the wavelength, they will be diffracted. Based upon this lambda, they will be diffracted. So here you could see that it is a optical signal which is having two components of wavelength, that is lambda 1 and lambda 2. And this light is incident at an angle theta I on this grating, which will be diffracted.
I divided
So the diffraction, angle of diffraction, that is theta d, you could see it is clearly visible that the
In place
theta
of
d
IB,
for lambda 1 is different and theta
IE
d for
minus
the lambda 2 is
IC.
different.
Okay.
And this
So
is
if
the
I want to
imaging
find out
plane.
this
So
term,
here on this imaging plane,
which term I'll divide?
The interference is being seen, observed.
IE.
Interference is being observed. So here we will have a constructive interferences. We will have constructive interferences on this imaging. So now we can for the constructive interferences at a wavelength lambda, for a particular wavelength lambda, which will be occurring on this imaging plane, when the rays are diffracted at an angle theta d, so it should satisfy this grating.
Anyone derived?
This is called the grating equation. This is called the grating equation. That is the
IE divided by
that is this
IE minus IC.
delta. Okay, this
So IE divided by IE
okay, we say this is grating period.
by
So grating period multiplied with
IE
sine of
minus
theta
IE minus
theta d
IC by
should be equal to m of lambda.
IE.
Be equal
But we'll
to
get 1 by 1 minus
So this m
alpha.
we are
So
considering
gamma equals to 1 by 1 minus alpha.
we are considering first order diffraction. Okay, we are
Now you
considering
cross
first order
multiply and
diffraction.
tell me
First order diffraction,
alpha in terms
here
of
m is
gamma.
considered to be 1. M is considered to be 1. For all our practical cases, we will be considering the first order diffraction where m is equal to 1. Okay. Right. So now let's take an example where we could use this circulator.
I will find
circulator and fiber
cross multiply
grating.
gamma
Okay, we
into
can
1
use
minus
this fiber
alpha
grating
equals to 1.
grating
That implies gamma minus
design
alpha
to
gamma equals to
add
1.
and
Minus 1 by gamma.
add and drop.
Sorry?
Gamma minus 1 by gamma.
So here you see
Gamma
that
minus 1
with the
divided
help
by gamma. Okay. Which is equals to, in terms of beta, what we have found out, beta by 1 plus beta. So I can write here, this is
we
beta
have considered a three-port
by
circulator, optical
1
circulator.
plus
From
beta.
the port 1, I am
So
giving
this is the relationship
optical signal
between
which
alpha,
consists
beta
of
and gamma.
lambda
Any
1,
one
lambda 2, lambda
parameter
3,
will be
lambda 4.
given, you can
Now
find
this
other
port
parameter.
is being circulated to
Okay.
port 2.
So this
will
is
be
the
going
syllabus
along.
up to mid-sem.
Now there is a fiber
Alpha, beta,
fiber
gamma
bragg grating.
relationship.
There is a fiber bragg grating which is acting
Now
as a filter.
we'll do some problem
And,
here.
This fiber bragg
Is it
bragg
completed?
grating which we have designed, which we have used, is passing lambda 1, lambda 3, and
All of you
lambda
have
4.
written?
It is passing lambda 1, lambda 3, and lambda 4, and it is diffracting. Okay, it is reflecting. It is blocking lambda 2. Okay, so it is reflecting lambda 2. So which is being fed as input to port 2, which will be circulated to port 3. So which will be coming out as dropped wavelength. So here, with the help of the circulator and fiber bragg grating, we could drop lambda 2. And which type of fiber bragg grating? It will depend upon this relation. It will depend upon this relation. What will be the grating size and everything, or grating period, that will depend upon this equation, right? So for what lambda we want to we would want to block,
Have you written?
given by this equation. Now, so here,
Yes, sir.
test
Yes,
common, circulators
Okay.
and fiber.
No, I'll write the question here.
Fiber drag
You
grating
try to solve.
require to design or to drop each wavelength. Okay. So how many for this 4 input wavelengths? How many circulators and fiber drag gratings we will require to demultiplex it?
Calculate IC and IE for a transistor that has
So with the help of one circulator and one fiber drag
alpha
grating,
equals to
you could, drop
0.98
one wavelength, right?
and
Similarly, next 3 are there, so you will use another circulator
IB
and a
equals
fiber
to
drag grating for a particular wavelength that will be dropped.
100
So now you are
microampere.
left with 2, so you will get another one.
Also,
So if you have n
and
wavelengths,
beta.
okay, if you are designing n wavelength combining multiplexer or n wavelength,
whatever equation we have
you
found
will
out,
require
using
n
that you
minus one
try to find.
fiber drag gratings and n minus 1 circulators. You will require n minus 1 circulators. So here in this case, where we have considered 4 wavelengths, right? So we will require 3 circulators and 3 fiber drag gratings for combining and separating this 4 wavelengths. Understood? Okay. So now here I have taken example of combining or multiplexing 4 wavelengths. 4 wavelengths. How I can multiplex 4? So
sir, IC 4.9.
Yes.
So here you could see
Unit
I have used one circulator, that is C2,
Sir, ampere.
and, which is
milliampere, microampere, ampere.
It is given lambda 2.
Sir,
And here I
ampere.
have a fiber drag grating,
No, no.
which
Check
is
again.
blocking lambda 2, which is this fiber drag grating is blocking lambda 2. So when this lambda 2 is being circulated to this port, okay, port 2 of circulator 2,
IC equals
which
to
will be given as input, and when it passes through
beta
this,
IB.
and when falls on
Beta
this
equals
fiber
to
drag,
alpha by
fiber
1
drag
minus
grating, so it will be
alpha.
reflected.
Right.
It will be reflected.
So
that's why
0.98
reflected
divided by
on
1
this
minus
fiber,
0.98.
to this input port and lambda 2.
How much you are
And
getting?
From this,
49.
we are getting lambda 1. So
49.
lambda 1 it will pass.
So
So
49
here, from the
into
from the input of this
IB.
port, you
IB
will have
is
lambda 1 and
100
lambda 2.
into 10 to the
That's
power
why
minus
the
6.
output from this port is coming as
So how much you are
lambda 1
getting?
and lambda 1 and lambda 2, which will pass through this fiber drag grating FBG3.
4.9 milliampere.
It will block
4.9
lambda 3. So
milliampere.
when I am passing lambda 3 from this input, right, which will be
Okay.
circulated to this input,
Then
okay, input port.
we have found out beta, we have found out
When it
IC.
will pass
Then
through- when it will pass
IE
through
need to
this,
find
part
IE
and
equals
it
to
will be reflected by
IC
this
plus
fiber drag grating.
IB.
And
So IC is
lambda 1 and
4.9
lambda 2 and lambda 3, and
milliampere
that will be
plus
passed,
IB
that will
is
be,
100
that will be
microampere means
circulated to the
0.1
next port. So from
milliampere.
this port,
That is
we are getting lambda 1, lambda 2 and lambda 3. Combination of lambda 1, lambda 2 and lambda
okay.
3, which will pass through this FBG4, that is fiber drag grating 4, because this fiber drag grating FBG4, it is blocking lambda 4. It is blocking lambda 4. So
Is it
will
clear?
pass Lambda 1, lambda 2 and lambda 3. Okay. So
Yes, sir.
from this port, lambda 4 is
Yes,
coming. It is being circulated to this. When it is coming, it is being reflected
Now,
back. So that is reflected back.
let us consider another
It will be
question.
circulated along with this lambda 1, lambda 2 and lambda 3 to the next port. So from this port, you will get lambda 1, lambda 2, lambda 3 and lambda 4.
A transistor
this way,
having
we are multiplexing. Here you could see we are multiplexed
alpha equals to 0.
wavelengths. We are multiplexed 4 different wavelengths.
975
This is how we are performing
and
the multiplexing. We are performing the multiplexing, optical multiplexing. So we are
reverse saturation
performing
current.
Optical multiplexing. Okay, this is optical. These are passive components. We are working in the optical domain. So we know that
ICO equals
passive
to
components, it will
10
be
microampere.
completely in optical domain, right? So we are not converting from optical to electrical. There is no conversion.
Operated in
It is completely in optical domain.
C mode.
And next is
Find
optical add and drop multiplexer. So this
beta
the function of this optical add and drop multiplexer
for
is
this
to add, that is insert, or to drop, that is to extract
configuration
one or more required or desired
if
wavelengths at a particular
IB equals to
designated point in the
250
optical domain. So here for
microampere.
this add and drop, we use MEMS.
Calculate
Okay, we use
the emitter current
your mirrors,
And IC.
reflecting mirrors. We use reflecting or we use miniature mirrors.
try to find
So here we have a 4x4 add and drop multiplexer. So suppose in this example it is shown that we have lambda 1, lambda 2, lambda 3 and lambda 4 which is being passed through this add and drop multiplexer. So if there is no changes, so it will pass through this port, right? So from here you will get lambda 1, lambda 2, lambda 3, lambda 4. Now I want the lambda 3 to be passed through this port.
transistor alpha is given,
Lambda
leakage current is given, operated in
pass
C
through
mode,
this port. Okay, pass through
find
this port.
beta
So what
and
happens?
IC and IE.
Here there are mirrors. Here there are mirrors.
So here
we
one
will
thing you need to
get
understand,
this mirror. We will open this
IC
mirror. So what happens? We
O
will
is
open this
given.
mirror.
So
whatever,
ICO means
light which is coming, it
by
will be
default
reflected and it will
it
be
is considered as
passed through
ICBO.
this port. It will be passed.
So ICO is
Earlier,
equals
we
to
had 4 inputs and 4 outputs.
ICBO.
But now when
Default.
this output is being blocked, this output is being, or this wavelength is being dropped, this wavelength is being dropped to this destination. Right. So
Okay.
from this
If it is not given in the
output,
question,
we'll have 1, 2,
ICO,
and
because
3.
we have already known
So now
that leakage current for
what we
common
can
base
do
is
is,
ICBO,
we can add-
for common
we can
emitter
add
ICEO,
a
for
wavelength.
common
We
collector
can add a
ICCO.
wavelength.
So if ICBO is given, directly you can take. But if ICO is given, then you understand this is given for common base configuration, that is
So we can
ICBO.
add
Okay.
a wavelength. How we can add? From
Now,
this port, we will pass a
Alpha is given, you can easily find beta.
wavelength.
So beta equals
We
to
pass
alpha
a
by
light, and from
1
here
minus
this,
alpha,
mirror
that is
is being
0.975
reflected.
divided by 1 minus 0.
Disturbed. The capacity is not.
What is the answer?
39.
39.
The capacity is not.
Now IC and IE we want to find out. So IC equals to what? Beta IB plus leakage current ICEO. Now beta we have found out, IB is given, ICEO is not given, but ICBO is given. So what is the relationship between ICBO and ICEO?
So these are the different passive
39 into 250 into 10 to the power minus 6 plus ICEO equals to what? 1 plus beta into ICBO, right? So 39 into 250 into 10 to the power minus 6 plus 40 into 10 into 10 to the power minus 6. Now find out what is the value in milliampere.
So next, we require an amplifier. In WDO networks, we also require an amplifier. And so, an optical network.
How much you have got?
Which, is using
10.15 milliampere.
different multiplexers.
Very good. 10.15
So
1 milliampere.
milliampere.
it requires.
This is your IC. So next,
Fiber
this one we have found out.
Fiber
This one we have
amplifier.
found out.
So
Now IE. So IE
and
equals
this
to IC plus
fiber amplifier.
IC is 10.15 milliampere
It has a significant
plus
role while
IB.
designing
So
this
IB is
WDM.
250 microampere means 0.25 milliampere.
WDM technology together with EDFA allows the transmission of multiple channels over the same
10.4
wire.
milliampere.
And that makes it possible to transmit many TB of data over a distance of hundreds of kilometers. Okay, and this distance is transoceanic.
Understood?
That means between two continents we can transmit the data. So there you are using this EDFA, that is a erbium doped fiber amplifier. The next component, this is one important component
Could you proceed?
in our WDM technology. That is the erbium doped fiber amplifier.
Yes, sir.
Yes, sir.
Now,
And the main key feature of this iridium doped fiber amplifier
an
is-
NPN transistor
which is basically a conventional silica fiber which is doped with iridium.
alpha
And,
equals to 0.98
And
is
this EDFA
Operated
it consists of a pump laser,
CB mode.
pump laser, and wavelength division multiplexing combiner. Okay. So this WDM combiner
IE equals to
is for to combine signal
3
and
milliampere
pump wavelength so that they can propagate
and
simultaneously through this
ICO equals
iridium
to
doped fiber. Okay. So
10
we have
microampere.
three components. It
Fine.
consists of basically three components. One is your
IB
iridium doped fiber.
and
Then we have a pump laser and a
I see.
WDM combiner. Okay.
common base configuration.
This iridium EDFA,
Find IB and IC.
this EDFA can be designed that the pump energy which will be propagating in the same direction as the signal. Okay, same direction.
So what is the equation for common base configuration?
Or we can design in the opposite direction to the signal,
IC equals to
or in the both direction. So this EDFA
I is
whatever
given.
we design,
So in terms of IE,
can
what is the
pump
equation?
The energy, it can pump the energy which can propagate along with the fiber
Alpha
in the direction of the signal,
IE
or in the
plus
opposite
leakage
direction,
current.
or it can travel in both the
ICBO.
operate in the both directions.
Okay.
And
So
the
alpha is
pump
given as
energy
0.98
maybe
into
and that
IE
is the wavelength
3 into 10 to the minus
okay.
3
The
plus
pump energy
ICBO.
maybe
ICBO means
in,
ICBO equals to
in
ICBO.
around,
So
980
plus 10
nanometer or
microampere.
1480 nanometer. 980 nanometer,
How much?
1480
You tell me.
Or we can have the combination of both. And the most common configuration is the forward pumping
Then I equals to
at 980
IC
nanometer pumping.
plus
Because this
IB, that
configuration
implies
has the advantage that
IB equals to
980 nanometer semiconductor laser
IE
diode,
minus IC.
with
So
which
IE is
features-
given, IC you
which
calculate
features,
to find IB.
effective cost.
So first tell IC,
It has
what is the value of
effective,
IC?
it has reliability and low power consumption. And providing this overall design, the performance and cost are being trade off. So we need to obviously when you
2.95.
the cost block increase. So we need to take
2.95.
2.95 milliampere. So 3 milliampere minus 2.95 milliampere. So IB always represented in microampere. Okay. So 0.5 means 50 microampere. Okay. So this is the value of IB. This is IC. Here. have written.
Okay. Now, if you see this amplifier, so here we are using a pump. So which is boosting our optical signal.
Series 3 is not visible.
Now
Yeah.
I'll draw a circuit here. Let us
Yes, sir.
try this problem.
So we have
So-
three components. That is your EDFA fiber. That is EDF. Then we have a pump laser, and WDM combined. So
5 kilo
this
ohm.
is the signal which is coming. The signal which is
310
this being detected. The signal is
Kilo
being
ohm.
detected. Okay.
20
Based
volt.
upon that, we will
10 volt.
from this control unit, we will pump
This
the
is grounded.
signal. Right? We will pump the signal. So that signal will combine with the help of this pump combiner,
You see.
and then it is passed through the pipe. Okay. So this is nothing but a
Okay. So
EDFA, that is
the
lithium
transistor
doped fiber amplifier. Lithium doped fiber.
is in C mode.
So this is also a
Calculate
passive component. So here this
VCE.
we are still working in the
if
electrical domain.
Beta equals
optical
to
domain only. There is no conversion from electrical
125.
to electrical, or there is no
assume
reverse conversion from electrical to optical. Okay, so this is also a passive component.
okay. So this is the circuit
The
given.
next,
You have to find out output voltage between collector and emitter, that is VCE. Beta is given and VB is given 0.6 volt. So how to solve this type of problem?
The signal will be the optical signal will be.
We need to find out
That's why
VCE.
it is very
Okay,
essential
this I want to find out.
or
So
to-
if I apply
it is very
KVL
essential to have optical signal amplification
in
so
this
that
direction,
the optical
because
so
this
that
is
we
VCC
can restore
and this is
our
ground.
optical power consumption.
So
So that the
we can
signal
move
level is maintained.
like
Signal
this.
level will be maintained.
So what is the current?
That is the reason why we
This is your
generally
IE.
used EDFA.
This is your
Okay, so
IB.
and this EDFA
This is your
designed
IC.
to directly amplify
Okay.
the input
So
of
I'll
the
start
signal.
from this point.
Okay.
So this is
And,
20 volts.
which eliminates the
Apply
need
KVL.
of transformation from electrical transmission
In output
transformation
loop.
from optical to the electrical. So,
So
here
VCC
it is a
minus
passive,
ICRC.
application, right? Because
So
it's a passive
IC
component. So there is
into
no conversion
RC.
from electrical to optical.
5
and
kilo
then,
ohm.
optical to electrical.
Then
and there is no
I'm
optical,
moving
electrical to
from here
optical
to
conversion
here.
is not required.
Then
So
this
here
is plus or
we are
minus.
performing optical amplification.
Plus minus means
Okay.
minus.
And it is it's simply it
Minus
can,
VC
amplify, it can
equals
simply
to
amplify
0.
all the WDM channels.
So
It
VCE
can amplify all the
equals
because
to
if you have
VCC
lambda one,
minus
lambda two, lambda three, lambda four, so it
IC
will amplify
RC.
all the
So VCC is
wavelength. It's
20
not, amplifying
minus
only a single wavelength.
IC we don't know,
All the
RC
wavelengths. Okay.
5 kilo ohm. So if I find IC, then I can find VC. So how to
And,
find
this
IC?
EDFA deployment is very easy.
IC,
when
we know IC
compare
equals to beta
to
IB.
the other amplification modes.
If I know IB, then I can find IC. So apply KVL in this loop. This is another loop. So apply KCL as KVL
So here,
in the
see, suppose there are 4 different
input loop.
users.
So
for
if I
4 different
apply
wavelengths. you remember
Then
text,
what I'll
it
get?
will pass through the optical
10
filter.
volt, that is
We are
VCC
splitting it
minus
and
IBRB.
detecting it.
So IB
Okay. So here we have used WDM system
into RB.
without
RB
EDFA,
is
without EDFA.
310
There is no
kilo
EDFA.
ohm
No,
minus VB
here
minus
we have used a WDM
VB equals to 0.
EDFA.
Okay.
With EDFA.
So I have applied across output loop
So
as
here
well as
we are
input loop.
using-
From input
we
loop
are
I'll get
using
IB, then
the
I'll replace this
EDFA.
one in output loop.
We are boosting.
So what is my IB?
We are boosting. Again, we
10
have used
minus
we have
0.6 divided by
used your EDFA, that is
310 kilo ohm.
fiber.
Tell me what is the answer? What is IB in microampere?
So
9.4 divided by
system.
310.
in a system with which uses EDFA. Okay. So when you compare with this, the
Point 0.03 10 by minus 3.
In microampere, you tell me.
in this there are two components. There is amplifier.
So 0.03
0.03
milliampere.
milliampere. Okay. But you should always convert to micro. Okay, because base current is small current, so you have to convert it micro. Anyway, now you want to find out IC. So
with this, we have finished our
IC equals to
WDM
beta IB.
concept, and
So
it's,
beta how much it is given?
components.
125. So 125
definitely
into
getting, some
0.03
based on this.
into 10 to the power minus 3.
So on Friday,
How much you're
we shall
getting?
have a quiz from optical sources to WDM concepts.
3.75
Quiz at
3.75.
11 a.m.
milliampere.
Is it Friday or Thursday?
Now you replace this one here
Thursday you want?
and tell me what is
Yeah,
VC.
Thursday. Okay, we'll keep Thursday. Okay, so Thursday we'll keep Thursday at 10. No, Thursday we have holiday, right? Thursday is holiday, right?
1.25
Thursday, Friday, both days are holidays.
Okay, that's what I'm saying. So Thursday we'll keep Thursday 11. Shall we keep
1 point.
Thursday 11? I will be sending you the assignment also. Assignment 2.
1 point कितना?
Okay.
2.5 sir.
So this is the way how we'll solve the question. So
Please
different
mention your
questions
roll
will
in the
come,
chat box.
different type of equations are same, but you have to process with different idea. The same question I can give with another type of figure. Have you completed this one? Have you written? Here two different voltages are connected. You can connect single voltage also. So that question I'll give. See here. Get the transistor. Like this. So here RP is connected, then one voltage source, resistor, here it is connected. So this is V, VB, VCC, RC, here IC equals to 1 milliampere, IB 25 microampere, this is IE. So question is calculate alpha, beta for the transistor given in figure if IC equals to 1 milliampere, IB equals to 25 microampere. This is the first part. Second part, determine the new base current to give 5 milliampere IC. This is part A, this is part B. So how to solve? IC and IB is given and it is asked for alpha and beta. Okay. Very simple. Beta equals to IC by IB. IC
Sir, beta 40.
beta 40. So calculate alpha beta, and if you know beta then you can calculate alpha. Alpha equals to what? Beta by 1 plus
Beta by 1 plus beta. Sir, 0.975.
Now what is given? This first part is complete. Alpha, beta you have calculated. Determine the new base current to give IC 5 milliampere. New base current means for a transistor, you remember this alpha, beta are constant until the temperature is constant. Okay. So here it is asked if here IC is 1 milliampere. Now from 1 milliampere to 5 milliampere, if I want to change my IC, how much IB should be so that beta is constant, because beta is constant for transistor at constant temperature. So how will solve?
सर तो 5 by 40 हो जाएगा ना?
हाँ वही तो पूछ रहा हूँ. So beta equals to IC by IB. Beta will constant. So IC changed. I want to find out IB. So IC by
Sir, 0.125.
you convert to microampere because base current always small, so you convert to microampere. Tell me.
125 हो जाएगा.
5 milliampere divided by 40, 125 microampere. Okay. So next class, tomorrow, we'll discuss about the input and output characteristic of different configuration. Wednesday, we'll take a test, class test up to this, the midsem syllabus. So up to this point, whatever question I'll set, and that will be Wednesday's exam, class test, 5 mark.
So then tomorrow we won't have the quiz.
No, tomorrow no. Wednesday will take. Tomorrow,
Sir,
if you want,
sir,
we can
sir,
take.
Tomorrow's
Sir,
quiz will be taken on Wednesday.
हाँ.
Okay.
Wednesday holiday नहीं है ना?
No, sir.
So Wednesday.
Thursday or
वेडनेसडे को क्विज सर बढ़िया.
हाँ वेडनेसडे करेंगे.
हाँ सर.
कल थोड़ा इनपुट
Wednesday during class hours.
ड्यूरिंग क्लास आवर.
okay sir.
ओके सर.
तो 5 मार्क्स का तो 5 मार्क्स का
5 मार्क्स.
सर न्यूमेरिकल्स प्रॉब्लम ही रहेंगे ना.
हाँ न्यूमेरिकल भी
10
रहेगा.
questions or 5 questions sir.
5 क्वेश्चन.
Okay sir.
Question will be more than 5. Okay. Maybe 10 question.
टाइम सर.
10.
टाइम कम दीजिएगा सर. लास्ट
सर
टाइम
टाइम बहुत कम था सर.
Time will be more this time.
सर कैलकुलेशन टाइम लगता है.
होता सर.
हाँ, I am giving the question according to time only. Okay. Wherever it is more time required, I'll give more time. No problem.
Yes.
So
सर टोटल मार्क्स.
total mark 5 बोला ना अभी.
ओके.
Okay. Wait, I'll take the attendance.